So let's talk about 1.3, Foundations of Math 30. We've talked about, in 1.1 we talked about simple interest. 1.2 was an introduction to compound interest, so you know kind of how it works. 1.3, we're going to talk more about compound interest, and we're going to develop an equation for finding future value for compound interest, similar to what we did with simple interest. Okay? But before I just give you the formula, I want to just walk you through an example so that you can kind of see where this formula comes from. Because I think down the road it'll be helpful for you, kind of as you move through this chapter, it'll be helpful for you to understand where this comes from so that it's easier for you to remember and to use, and for you to choose when it's appropriate to use. Because every question is not going to be use simple interest formula to calculate the money earned. It'll be, you know, a little more coded than that, so you'll have to understand the situation. All right, so let's take a look at this first little bit here. It says, learn about the math. Yvonne, this appears to be Yvonne, earned $4,300 in overtime on a carpentry job. She invested the money in a 10-year Canada Savings bond that will earn 3.8% compounded annually. All right, so now what does compounded annually mean? Well, here's the definition over here. You might want to jot this down into your notes. Compounded annually means the compound interest is determined or paid yearly, so once per year. So compounded annually means compound interest is applied once per year. And yes, we are going to be having different compounding periods. So not just once a year, there will be other periods that we'll consider. So she decided to invest in a Canada Savings bond instead of keeping the money in a savings account because the CSB will earn more interest. Now the question is, what is the future value of Yvonne's investment after 10 years? All right, so I'm just going to walk you through this. You don't have to copy all of this down, but let's just walk through the example as it is presented here. So the principal is $4,300. Okay, the yearly rate of interest is 3.8%. Or remember, you have to use a decimal, unless you have a percent button on your calculator that you use. I'm not sure, but it's always safe to just put that into a decimal. Move the decimal place back 2 times. So it's 0.038 is the decimal form, and we're going to go for 10 years. Okay, so at the end of year 1, this one's pretty straightforward because we only have the principal to consider. We can use the same future value that we used for simple interest for the first year, right? So 4,300 times 1 plus 0.038 times 1 for 1 year. And this is what we get. Okay, so that's how much the investment is worth after year 1. Now with simple interest, we would use the same amount of interest to add on every year. But with compound interest, now what we do is we use this new number right here. And so hopefully this is ringing a bell. Okay, hopefully this is making sense from last lesson. But this is how it's calculated. So here's year 2. Take the new amount and then multiply by the percent. And then for 1 year, for the end of year 2. And so we get yet another amount here. Okay. And then we use that amount for year 3 and so on. So we can do this 1 year at a time, but what we see is some patterns, right? And here's a visual of the pattern that we see. So here's the initial amount, or I guess, no, that's not the initial amount, was it? No, that wasn't the initial amount. That was, when was that? Anyways, I guess this is after year 3. So this is year 3 here, sorry. And then after year 3, we go again. Again, another 2 years after that, and so on. So you're building, I guess you're building up to this amount. So this is what I want to focus on with you right here. I've copied this into our notes. And again, you don't have to write all this down yet. We're just kind of seeing how this plays out. So look at what's happened after 3 years here. And this is really, really helpful. You have your principal. And then the first year, we multiplied by 1.038. So that's basically 103.8%. That's what we want after the first year, 103.8%. For the second year, we take this amount and we multiply by this again. And then so on. For the third year, we take this amount and we multiply by this again. And so this is key. I'll zoom in just a little bit here, but this is key to the process of understanding where this formula comes from. We have our principal, and then we have this 1.038, that's 1 plus the interest rate, and we've done this 3 times. So at the end of 3 years, we have an exponent that is the same there. We have that exponent of 3. If we continue this pattern, we would be multiplying the principal times 1.038 exactly 10 times to get our future value after 10 years. Okay? So this is very important. If you look at this right here, this is the basis for our formula for future value for compound interest. We have inside this formula P, okay? We have inside this formula 1 plus the interest rate for the year. And guess what this is? This is the term, okay? And so from this pattern, we can see that we have a future value formula. And you can write this down now, because this is really important, okay? So, let me, oh, come on. Zoom out a bit. Okay, so here's the formula for future value. Remember, A is future value. P is the principal. This little I is the interest rate per compounding period. Now, you may remember that we used little I before for the amount of interest. So from now on, the amount of interest in simple interest is going to be capital I, okay? And I noticed they did that in this book after I initially showed you that. So the little I here now is going to be the interest rate per, and this is important, which I'll talk about in a minute, per compounding period. So if it's annually, that's the rate every year, the yearly rate. Now N represents the number of compounding periods. So again, you're going to want to just jot this down, what I is or what N is. Very, very important, because that's what's new here in this section. Okay, so once again, little I is the interest rate per compounding period. And N is the number of compounding periods in total. So if you think back to this example, I was 0.038 because that was per year, right? And so per compounding period was per year. And the number of compounding periods, well, it compounded once a year for 10 years. So that's a pretty basic, really simple, straightforward question. Now I'm going to go back to the textbook here, because I'm going to explain compounding periods for you. Okay? So here's compounding periods. If it's per year, it's just the number of years in the term. But the compounding period is the time over which interest is determined. Interest can be compounded annually, as in our first example. It can be compounded semi-annually, every 6 months, or it could be compounded quarterly, or monthly, or weekly, or even daily. So really, right down to every day, the interest can be compounded. And I believe that in some credit cards, if not all, don't quote me, but credit cards compound daily. And so do you think that you would, if this was your investment, do you think that more compounding periods would yield you more money, or fewer compounding periods? Which one would make more money? Fewer? More? Okay. Is there a vote? So let's think about it this way. As I said, the credit card companies charge you interest for everything you put on their card daily. So do you think they're going to want to get more money from interest from you or less? They're going to want to get more money. Their interest rates are really high and they compound daily. So they're actually getting more interest when you compound more times. Okay, now it's not the yearly rate every day. It's not the yearly rate every day. It would be the yearly rate divided by 365. So it's still a portion of the yearly rate. However, the more times you compound every day, think about it. The total amount that you can charge interest on goes up by a few cents or whatever it is every day. And so that still is going to grow a little bit quicker than yearly. So that's the compounding period. So N and I will be what changes here for different examples. Okay, any questions? Yes?
So can we say that I equals to RT?
Well, can we say I equals RT? Well, I'm going to show you how to calculate I. Okay, so the interest rate per compounding period. We're going to look at another example here. So I think we'll take a look at this one here. Okay, this is example 2 in your textbook on page 22 if you want to follow along. So let's read through this example. It says Matt has invested a $23,000 inheritance into an account that earns 13.6% compounded semi-annually. Okay, so that's a pretty good percent right there. That must be some kind of really aggressive sort of investment portfolio, meaning that it might be a bit risky, but compounded semi-annually. Okay, so how many times per year is semi-annually then? Twice per year. Good. Every 6 months, that's right. So the interest rate is fixed for 10 years. Matt plans to use the money for a down payment on a house in 5 to 10 years. So that's pretty smart. Put that stuff away. What is the future value of the investment after 5 years, and what is the future value after 10 years? Okay, so if we get into this right now, we have some information that we can use, but it's compounded semi-annually. So what we have to do is we have to take into consideration this percent, but that it is actually used twice a year. Okay, so here's where we get our I from. Okay, so the rate is 13.6 per year. There's 2 periods per year, so you have to divide that percent by 2. And so what that means is the interest rate that we'll use in our formula is actually half of this one, or 6.8%. Okay, so if we look back here, okay, to calculate I, you take the yearly or annual interest rate and you divide it by the number of compounding periods that are in this yearly rate. So in this case, it would be half of this divided by 2. Everybody get that? So that's the first thing you're going to have to remember to do with I. Now with N, okay, with N, it's not simply the number of years of the term. If it's compounded semi-annually, that means there's 2 periods per year, right? There's 2 compounding periods per year. So you simply multiply the years times the number of compounding periods per year to get N. All right? So for this example, and again, I'll just write down just on top here just some of the information. Okay, so we have a principal of $23,000, and we have a yearly rate of 13.6%, and we have the term of 10 years. So the first question really asked us, what is the value of the investment after 5 years? So we're going to find A, right? So A is what we don't know. The principal is $23,000. And we multiply that by 1 plus, now remember I is the interest rate per compounding period, so it's right here, 0.068. And N would be the number of compounding periods after 5 years, which actually is 10. So that's to the power of 10. So any questions or problems about what I've done here? And again, just once again, this I is important and this N is important. Okay? Okay, so take a moment to evaluate that on your calculators. Just make sure you can do that. Make sure this is to the power of 10. It's not scientific notation, right? It's not exp times 10 to the power of 10. It's not that. Okay, it's just to the power of 10. So you got to find your power button. It's right here on this calculator, this little hat button. You might have a y to the power of x button or something like that. Okay. One thing you have to remember here when you're doing this is not to multiply this first. Do not do this first and then take it to the power of 10. Order of operations say that you have to do inside the brackets first, remember BEDMAS, brackets, then exponents, then multiplication, division, then addition, subtraction. So that's what you should get there. Now, my question to you is not in the textbook, but let's say that these compounding periods were only once per year and not twice. So let's just test that out to see if we were right about the whole more compounding periods make more money or make more interest or whatever it is. So what I want you guys to do is I want you to do this. I want you to do A, 23,000 times 1 plus, now let's do the full percent, okay, 13.6%. That would be, in decimal form, would be 0.136. And then let's just do compounding periods 5. So let's test the full yearly percent to the power of 5. And let's just see how that compares to more compounding periods. And let's just test our hypothesis here. We'll see if the credit card companies really want to make more money on us or if they're just being nice. Okay? So I will also just see if my calculator can do order of operations on its own, which your calculator might as well. All right, so let's see if that's going to work here. Okay, so check this out. So $43,513. $43,513 and change. So you can see right away, the same percent, just more compounding periods, you're going to make more money with more compounding periods. Does that make sense? 0.05. So again, this is once per year, the full percent per year. Now we could test this as well if it compounded monthly, right? We would have 5 times 12 would be, the number of compounding periods and so on. But we'd have to divide this by 12. All right? So that's just something that you need to know. So it's good to confirm that. So that's after 5 years. Now we could do the same for 10. I don't think we'll go all the way through that. But if we take a look at the textbook there, they've run through this. So after 10 years, right? Oh, and here's some notation too that you might see in the textbook or on a quiz or something. A sub 10 here, that means the future value after 10 years. Okay? And so here's the same percent per year, it's per compounding period, for 20 compounding periods, and here's your value. Okay, so any questions on that example? Any questions about that? All right, let's talk about this rule right here. This is it's a kind of a general rule of finance and investing. It's called the Rule of 72. It's sort of it's based on a pattern, but it's kind of a loose rule. So this is what the Rule of 72 says. A simple formula for estimating the doubling time of an investment. That's what the Rule of 72 is. 72 is divided by the annual interest rate as a percent to estimate the doubling time of an investment in years. Okay? So if you wanted, let's say you wanted $2,000 to grow to $4,000. Let's say that was your goal. If you had the annual interest rate, if you knew that of your investment, then you could find out roughly how long it would take to do that. So that's what the Rule of 72 says. So let's just talk about that once more time. The simple formula for estimating doubling time of an investment. And what it is it's 72 divided by the annual interest rate. The Rule of 72 is most accurate when it's compounded annually. Okay, so obviously this is kind of a loose rule. It's not down to the cent. But let's say we had an interest rate of 13.6, just like this other question. So it looks like we go 72 divided by the interest rate, 13.6. What does that give us? Well, let's just test that out. Let's get rid of some of that stuff. 72 divided by 13.6 equals 5.29. So this answer is going to be roughly how many years we would have to keep this invested in order for our amount to double. Okay, so about 5.29 or 5.3, so 5 1/3 years. Okay, that's the Rule of 72. So you'll be asked to do some estimation there with the Rule of 72. Any questions? Now, that 5 years is actually pretty high because this is a pretty high interest rate. Most interest rates are maybe 3 or 4 or 5 at the most. So that 5.3 years is pretty quick turnaround, actually. That's not to be expected in a lot of circumstances. All right. Now, you may be asked to solve for I, like how much, what's the annual interest rate? You may be given future value. You may be given the principal, here, P, and you may be given the number of compounding periods, and they may ask you to find the annual interest rate. So if that's the case, you would have to solve for I, and then figure out, okay, is it compounded semi-annually? Then you would have to multiply that by 2 to get the annual rate. Is it compounded monthly? multiply by 12 to get the actual rate. Okay? So they could ask you for principal. They could ask you for I. They could also ask you for n. I'm not actually sure. Do you guys know the math to solve for n? Let's see. We've studied logarithms a little bit, right, in this class already? Okay, so depending on how familiar you are with logarithms, you can solve very precisely for n. If it's an exponent, you may just have to kind of do some trial and error for n if you're asked to solve for n, which is totally fine. But we'll cross that bridge when we get there. All right, so here is your assignment, 1 to 3, 7, and 13. And the first question is asked you to fill in the table here, which I've kind of already started for you, so you can get a start on that. I'll leave the suspense of the end here for you to uncover yourself. But here's the start. Okay, any questions about 5.3? I mean 1.3. In chapter 5 already. Questions?